What causes ice to melt? Ice melts when there is a heat transfer between it and its surroundings. As the ice gets warmer, the air and glass in this case get colder, ever so slightly. Today, we are going to learn how much heat needs to be transferred from an environment to ice in order to raise it to room temperature. Okay, so let's say we have 50 grams of ice. Its starting temperature coming out of the refrigerator was negative 16 degrees Celsius, and at room temperature, which is where it will end, is 23 degrees Celsius. Let's define a few terms. The specific heat of ice is 2108 joules per gram degree Celsius, but what is that really? Specific heat is the amount of heat needed to raise a certain substance 1 degree Celsius. In this case, it is 2108 joules per every gram of ice to raise it 1 degree Celsius. The specific heat of water, which is different from ice, is 4184 joules per gram degree Celsius. Now, the other term we need to understand is latent heat of fusion. That is the heat required just to turn an object from ice to water, or any substance from a solid to a liquid. That is the latent heat of fusion. So we have 3 steps when ice is being warmed to room temperature water. First, you have ice that needs to go to 0 degrees. Then, your 0 degrees ice needs to turn into water, which needs to then turn into 23 degrees Celsius water. The equation for heat required to change temperature of an object is MCAT. Q equals M C delta T, where M is the mass of the object being warmed, C is the specific heat of that object, and delta T is the change in temperature. T final minus T initial. Then to change the state from solid to liquid of the ice, we need Q equals ML, where M is the mass of the object and L is the latent heat of fusion. And then to change the water to 23 degrees, we again need Q equals MCAT. Okay, so let's figure out how much heat is needed to turn the ice from negative 16 degrees Celsius to 0 degrees Celsius. We have Q equals M C delta T, where the mass of 50 grams of ice, 50 grams, the specific heat of ice is 2108 joules per gram degree Celsius, and the change in temperature is 0 degrees TF minus negative 16 degrees. This results in 1,686,400 joules. That's how many joules of energy are required to raise the temperature of ice from negative 16 degrees Celsius to 0 degrees Celsius. Or written in kilojoules as 1,686.4 kilojoules, another common unit. Secondly, we need to turn the ice into water at 0 degrees Celsius. Yes, there is a heat transfer required just to change the state. So we use our equation Q equals ML. Q equals the mass is 50 grams, and the latent heat of fusion of water, 334 joules per grams. This results in 16,700 joules. So now we need to raise the temperature of our 50 grams of water that we have now to 23 degrees Celsius, room temperature. So we use Q equals MCAT, where we have 50 grams. The specific heat of water is 4184 joules per gram degree Celsius. And the change in temperature is 23 degrees Celsius minus 0 degrees Celsius. And that gives us 4,811,600 joules. All in all, we have 1,686,400 joules plus 16,700 joules plus 4,811,600 joules, resulting in 6,514,700 joules.